Okay, these are the terminals. No, let's get into this one. Let me use green color. You know some diode forward bias, reverse bias. So I'm going to bring that ideas. Now this is the emitter. This is a base, and this is a collector. Then there's a N type, P type, N type. I'll not show all that doping everything. Already we have discussed that one. So this is still for your convenient purpose. I'll write this as emitter, base. This is a collector. Okay, let's get into this one. It should be forward bias, no? So the N type should be connected to N type should be connected to what, like forward bias. So this should be connected to negative terminal, and then N type of the battery should be connected to negative terminal. So shall I use a cell like this here? So what this negative terminal will do? This N type connected to, so negative terminal of cell connected to N type, positive terminal connected to P type. So therefore this will be forward bias. I'll give the name. Books they given name VBB. Need to bother. No sir, I don't like it. Write EX, EY, any other symbol. For your convenience, I'll write EX. Then this collector base junction should be reverse biased here. Reverse bias means P type should be connected to negative terminal, and N type should be connected to positive terminal. So this is called as VCC. Any symbols, if you are getting confusion with VBB, you write EX and EY. Okay, this is about the overall condition. And we know always for a diode, we should bring one resistor in series. We always go for one resistor in series, no? To protect it from, since it is coming here, so I'll write it as RE. And this resistor, what happened to protect that from higher voltages, RC. To protect the diode from exceeding voltages. So I'll go for one resistor. I think it's very simple. Why circuit like that? Straight away, there's a base emitter junction. There's a collector base junction. Okay, there's a circuit. I think anybody can draw now, nothing big. So sir, how to draw this one? Collector base junction should be forward bias. There's a core idea. Base emitter junction forward bias, collector base junction should be reverse biased. Okay, what actually happens? Let's see that one. What actually happens? So let's assume that if 100 electrons, let me start with 100 electrons. So shall we take this is 100 electrons. This will send 100 electrons. This will push. Now look at this. This is 100 electrons will come. All these 100 electrons will come here. What are these? These are majority carriers, no? And so finally what happens? These 100 electrons will arrive here. As it is a forward bias, what do you expect? All these 100 electrons will reach here. Let me show the base little bit more width so that I have to explain some concepts. Actually be thinner than the emitter. Now what happened to these 100 electrons? The concentration of, here I'm putting 100, practically what happen, millions of electrons will be there. All these 100 electrons, what happen, they must become minority carrier, irrespective of their number with respect to holes here. P-type, what happened in P-type, who is majority? The holes are majority. All that 100 electrons happen, they're minority carriers. The concentration of electrons here are 100 and here is very less. So the diffusion will occur. So what happens to the 100 electrons? They'll start diffusing. When they are undergoing diffusion, some of the holes will capture electrons. If a hole captures an electron, if a hole captures an electron, if a hole captures an electron, what do we get? We get a valence electron. Okay, is that clear? I think electron we show like this, no? Recombination. If a hole captures an electron, free electron, we'll get a valence electron. So here, these 100 electrons, by the time when they reach here, so will become how much? The number will become 95. Where that 5 electrons had gone? Due to recombination. The reason for that base is p-type. Any number of electrons, not all will undergo recombination, few. So let's say 5%. Now these 95 electrons, can they cross? Here I put 95, practical open millions of electrons. So what is the reverse bias? It will offer resistance for what? To the flow of majority or minority carrier. To the flow of majority carrier. This is a reverse bias junction. And the reverse bias what will happen? Whom it will oppose? It will oppose the flow of majority carrier. Any number, minority carrier, let it be any number. I'm telling this one, I'm using word any number, not few, millions. I'm saying any number. Any number of minority carriers, let it be. It will permit all that 95 electrons will come here. You can show short here. You should ask one best question to the teacher. Sir, how come, sir, these are electrons? Either electrons or holes, what happen? The reverse bias will permit minority carrier. All these electrons, irrespective of their number, they are minority carrier in the p type of base. So they just permitted. Red carpet welcome for them by the base collector base junction. All these 95 electrons, now what happen, will be attracted by this. This 95 will come here. How many electrons enter, those many should leave. But what is the problem? Charge should be conserved, no? How many left the negative terminal of battery VBB? This is a cell. How many left? 100, no? Finally, I should get 100, but I am having only 95. So charge is not conserved. So there is some problem is there. So transistor is a device which will not obey law of conservation of charge principle. No, everything is built up based on law of conservation of charge only. So something is going on. Okay, let's see that one here. This is a positive terminal. What it does? It will pull 5 valence electrons from the valence band. How many volts were lost? 5 volts were lost here, no? And 5 free electrons. Will I agree this? Due to recombination. So I'll write here the commenter. 5 free electrons are captured by holes. So 5 holes, 5 electrons were lost in the base. Then if I switch off these cells, then what happens? Then the particular material will lose that 5 electrons, no? 5 holes. So, but if I go and check it afterwards, the same 5 electrons are available. So nothing, the material is in fact neutral. These are minority carriers. All these 95 electrons are minority carriers. They'll enter here. And already there's a positive terminal. It will pull out these electrons. If this were majority carrier, they will flow like this. But what is this? There's a positive terminal and there's a minority carrier. And we know that it will pull out like this, no? This battery is not pushing these electrons like this. The electrons are flowing like this here. There's a minority carrier, no? This is like all this, irrespective of the number. What very high number will be there, but still they are called as minority carriers. So they'll come like this. Okay, now 5 electrons are captured by 5 holes. So 5 holes and 5 free electrons are lost. What this positive terminal of cell will do? It will pull out 5 valence electrons from valence band. What do you get? 5 free electrons in conduction band, 5 holes in the valence band. And that 5 holes what happen will be there here only, and the 5 electrons which will come in conduction band will be pulled by this positive terminal. So like this what happen here, we'll get that these electrons. I'll show different color. So 5 plus 95, I'll get back the original 100. Like this, the flow of charge takes place here. If you make it base heavily doped, then instead of 95, what you get? You may get here only 70. Then 30 electrons will come. So therefore, by controlling the doping levels of base, what we can do, we can control this base current. Now let's come for this one. Electrons are flowing here. Opposite to that, what should be? Emitter current. 95 electrons are coming in this direction. Opposite to that, collector current. 5 electrons are coming here. Opposite to that, base current. Apply KCL, what you get? High E is equal to high C plus high B. This is a KCL for the transistor circuit. And what it is? NPN transistor it is. It is an NPN transistor. So like this will happen, this will be there. Okay, now you see this. What we are making, okay, there's a high resistance, no, there's a reverse bias. Actually, if you see this one, who is heavily doped? Emitter is heavily doped compared to like a base or pen. This is much heavily doped, no? So what the doping levels? I think if you can recollect some statement I have put it earlier class. Once again, I'll put it. I think many might have not noticed. Width of depletion layer. The width of depletion layer is inversely proportional to doping levels. Well, let's analyze some small. I'll come back to this topic because the concept we cannot understand without this. If both base, if the let me go back to the diode. If both are equally doped, then I'll reverse bias it. Is it fine? P-type, N-type connected. This is a cell. Then if both are equally doped means I'll put P and N. Both are equally doped here. Both are. We know depletion layer, no? So what the depletion layer? It will, the width of depletion layer should increase. So since both are equally doped, no? So how much depletion layer increases in the N type, that much what will increase in the P type. The width of depletion layer in both the regions will be same. We'll take this is X1 or XP, shall we write? Width of depletion layer. So what is the width of depletion layer? Okay, clear this. If both are equally doped, the depletion layer, when it is reverse bias, will penetrate equally in both the regions. No, if it is P is heavily doped, let's say that N is heavily doped. There's a core idea which is going to help us here. Otherwise, it will be very difficult for us to understand. No, I'm saying this is heavily doped and let this be moderately doped or say lightly doped. Tell me what happened to, it's a reverse bias, no? Then the depletion layer, what happen? Will penetrate more because you see like the one which is heavily doped, the width of depletion layer should be less in that region. So if I put a yellow color like this is heavily doped, the depletion layer will penetrate more into the P region. The one which is lightly doped, either P or N, we are not bothered. So what is this? This will be now XP and this is XN. So which will be greater? XP will be greater than XN. The reason for that, any reason? The doping levels are less. The depletion layer will have, the width of depletion will be more. And this box, I'll move it. No, is it okay? No. So as the P is lightly doped, no, so the depletion will penetrate more into that one. It can be either way. Sir, like suppose say that if N is lightly doped and P is heavily doped, then the depletion will penetrate more into that. I'll give that diagram also. They may ask you in exam. There's no discussion in none of the books here, but this is what we are going to take help to explain the concept here. I will show more. When do such a thing will happen? This is XP, this is XN. This is P, this is N region. Now, who is heavily doped? This is heavily doped. This is lightly doped. What is the total width of depletion? Again, XP plus N. W means width. Width it is. Okay, got this. So the doping levels are very important. Huh? There's a core idea of construction. Okay, now shall we get into showing depletion layers here? Now, who is lightly doped? There's a lightly doped, no? Moderately doped. How the penetration, the depletion layer should penetrate more into this region. First, let me write these things. Yeah. Anyway, base emitter junction is forward bias. There's no need to show the depletion layer itself. Is it justified? It's a reverse bias junction. Forward bias, no. For forward bias, the depletion will be very thin and we are not bothered also. If you reverse bias base emitter junction, okay, you could have again shown. Fine. This is, okay, now you can see that what we are doing, there's a high resistance region, no? There's a low resistance. Getting the idea? So what is this? There's a forward bias. Forward bias means low resistance. Reverse bias means what? When high resistance. What we are doing, we are making the current to flow from region of higher to lower resistance. Practically what will be very difficult. This is high resistance, almost like infinite. So what we put open circuit. Will I agree? The reverse bias, I think I gave one question, if you can remember, intentionally I brought that. This is like a two diodes connected back to back, no? Two diodes connected back to back. I'll come back to this discussion. So let me go back to the original discussion what we made earlier. If there are two diodes are there, so it is like this. Now analyze like this. If I connect it, the same circuit, there should be the forward bias, no? There should be the reverse bias. P type, this is PN, PN. Now, you must really answer. This was RC. You can bring wherever there's a RE. So there's a cell EX, there's a EY. Tell me like what is this diode? Forward biased. This is a reverse bias. Tell me what actually you see here. If you can answer this, I think slowly you are able to understand few little things. This is reverse biased. This is forward biased. That I'm very sure. Am I right? This is a reverse bias. Reverse bias means what you are going to do. Okay, this is okay. This is a reverse bias, no? Okay, now get into this one. Fine, yeah. Okay, look at no. Can you say anything about the currents here? I think there'll be only current flows here, no? So let me take that currents I1 opposite to that. So like, okay, current will flow I1, I1. No current will flow here. Why no current? Open circuit. Actually, how the circuit will be? There's a forward bias. So forward bias, what you are going to do? You are going to replace with a cell VBE. Agree this, and if any forward resistance are there, bring that forward resistance also of the diode. This is 0.7 volt. Open circuit. Why open circuit? Reverse bias. Open circuit, what we show? We show by very large resistance. So definitely how the current will flow like this only. When you connect two diodes back to back, this what happens. If you say S, then I'll go to the next one. Will you agree all of you? Yes, in fact, sir, okay, fine. We are very good in diodes. You give any circuit, will solve problem. There's a reverse bias open circuit. Forward bias, I'll replace with a cell, and it's having a forward resistance RF. What is the potential? I applied EMF such that it will forward bias and this will reverse bias. Sure short, no, this is how much, say like a 5 volt. This is how much, say like a 5 volt. It will reverse bias it. What is there in that one? If I say this EMF 2 volt, definitely see, I'm going to apply always in this, let it be say like a 5 volt. What is there in that one? I'll write it, values. Okay, you want values. So. Okay, this one. Are they not reverse bias and forward bias? Yes. No current should flow here, no? Will I agree all of you? If you say yes, I think it's good. If you say no, sir, current will flow means then I can't help you. No current will flow here. Here current will flow here. Is it okay? I think the same circuit, no? But in this diagram, what I'm showing, a current is showing. I'm showing the current. What is this? Something it's not good, no? Like, or your teacher is mad. I'll bring both the circuits at a place. Huh? If you're not thinking this much and going means, okay, you are just studying. I'll place everything in place. Okay, please do. Okay, no, I'll bring everything in one page. Please answer here, no. I think totally against the thing what, if you look at this, what I explained, no. So definitely this should be the wrong, because sir, open circuit, no current should flow. This is what happens when you connect two diodes, separate diodes back to back. This is called like a back to back. So once the diode came, no, somebody connected like this and check, okay, it's of no use. Better remove this diode, this cell. It's of no use, no, this circuit. It's of no use. Then what happened? The William Shockley, what happened? The three scientists, they came together. Instead of separating two diodes, they took semiconductor material. They added here pentavalent impurity. Here, very few trivalent. Here, moderately doped pentavalent impurities. Then they built up this particular structure. Then what happened? They connected a cells. They saw current here. What we think, no current should flow here. But if you connect two external diodes here, what are these? Two external diodes. These are diode D1, D2. Two external, what is the discussion? Two diodes D1 and D2 are connected back to back. Nothing will happen. But same thing, instead of two external diodes here, so if you bring total semiconductor material, silicon, pure silicon, then if you dope them, okay, clear this, then what will happen? Then if you join a wire and connect a cell, there is a current. So what actually this circuit is doing, it is here zero current, here zero resistance, no current is flowing. Here though I resistance, still current is flowing. So what is doing now? This called like it is transferring the current from a region of high resistance to low resistance. See, across low resistance current flows, okay, justified. Even open circuit, what we think open circuit, this open circuit, no current should flow. A current is flowing. So what this transistor is doing, it is making a current to flow from high resistance to low resistance. It is permitting. We are making it to transfer current from high resistance to low resistance. Practically, what we think is it should not flow. Means on paper. But what when if I go and check it, I'll connect emitter. A current is there here. I'll connect one emitter here, and there. I got a current. So therefore, what is it is transferring the current from across different resistance. Transfer resistance, transistor. That is the name. Got the idea? This one. So we think it's an open circuit, no current should flow, but actually current is flowing here. So I give explanation. Irrespective of any number of minority carriers present, millions actually practically, all are permitted because reverse bias will permit the flow of minority carriers. The reverse bias will permit flow of minority carriers. So this is open circuit. So I think now I should say goodbye to this. It's of no use. If you connect two external two diodes back to back, okay, no use. But if you construct that transistor like this, no, yes, there's a use. Don't call this a transistor, no, it's over. So we never show our transistor circuit like this. Got the idea? Finish. So there's a background. Why the name transistor? It will transfer resistance from region of high resistance to low resistance. That's why transfer resistance, transistor. It has become so popular that the radios earlier, even when I'm child, we used to listen the cricket commentary in radio much than television. The radio itself, what happened, is made up of transistors. It has become so popular that the radio set itself, we used to call it a transistor. You type in Google, transistors means what means it will show the device, what I shown earlier first diagram, and also it will show radio set. The radio itself, the radio set itself is called as a transistor. Like FM radio, what you have now, like we had earlier, the radio sets were called transistor. Got this? I think I'll take it out this because again, there's a two diodes connected like this. Okay, now I think I'll say goodbye to this. I'll say goodbye to this. Now let's focus on this one. Okay, let's construct this diagram. So what is a symbol like diode we have shown? No? Like actually this PN we have shown like this. Similarly, what is the transistor symbol? The transistor symbol we show like this. And I'll bring this circuit. I'm making things clear. So again, when we go for numerical, no, just KCL, KVL. Let's construct a circuit diagram because every time like this drawing like a base emitter, that rectangular blocks no will become problem. We'll go for equivalent circuit. Okay, if you see this, the transistor symbol NPN, emitter, base, collector. This what happened? We show like this. Base, collector, emitter. Agree this? There's a circuit symbol. Transistor will not be like this, or will not be like this. This will be like this only. It is given some suitable shape. So this is a circuit symbol, like a register. We show register like this. No? So this is a symbol. This is a physical diagram. Okay, NPN. So let me replace here. No. So this is the transistor. These are the terminals. No. So emitter, base, collector. Okay, let's construct the circuit. The emitter is connected to one resistor. Either you show it here, doesn't matter. Connected to negative terminal, then this one. Okay, agree this. So this is the battery, VBB, any symbols, VCC, and this is called as RE. This is what emitter current. The arrow indicates the direction of emitter current. I think it'll be much easier. So what about the other currents? Other currents should enter. So now base emitter junction forward bias, and what is this? This is N, no? This is P. This is N, NPN transistor. Similarly, PNP transistor, I can sandwich here what we did. We are sandwiched P between N. Similarly, I can sandwich N between P. So there are two types of transistors will come into picture. So this will be PNP. Emitter, base, collector. So what are the regions? Regions will be, this will be N, P, N. PNP. PNP transistor here, the direction of emitter current. So here emitter current will enter like this here. So base collector current will leave the transistor. So everywhere KCL you are going to apply it. Either NPN or PNP transistor. IE is equal to IC plus IB. The arrow here indicates the direction of emitter current. I think you have to keep it here. So depending upon the application, either I can go for NPN transistor or PNP transistor. Little bit thick letters you show it. Okay, fine. Now, what is the why the shall I call this as a biasing circuit? Biasing. What are RB, RC? So what is this? This called like a biasing circuit. No? RB, RC, VBB, and VCC are components of biasing network. Agree this? These are the components of biasing network. So what do you mean by bias? I will make the emitter base junction forward bias, collector base junction reverse bias. For that I need cell and a resistor. So I am bringing. So why I am connecting cell and the resistors like this only? Again, the background is what? Two junctions are there to provide biasing across the junction. That's why this network is brought. On its own, they cannot have the bias. Agreed? So this is about the circuit here. Okay, this is now you can see the base. No, this is common. So I'll put it Hertz symbol. Here I'm going to I said amplifier. No, now this amplifier circuit. The electrical signal which has to be amplified, I'll supply it here. I'll apply it here across these two terminals, and I'm going to collect the output signal here. So therefore, this will become input section, where I'm going to feed the signal, and here I'm going to collect output signal. So the mic, I'm going to connect it here, and the loudspeaker, I'm going to connect it here. And this circuit will amplify the signals. Getting the idea now? So therefore now, this called like a output, this one. So tell me what is the gain now? Collector current by emitter current. So how you define gain? The gain, what when we define the output current by input current. So what is the output current here? The current flowing in output section, the current flowing in input section. And I'll call this as a common base amplifier, because base is common for input as well as output. So what is the circuit, what I'm describing? It is a common base amplifier. I'll give name. No, we'll name it. Common base amplifier. So I'm interested in that current gain. So what is the current gain? Output current by input current. What is output current? Collector current. What is input current? IE. The symbol for this is alpha will give. What is IC? IC should be less than IE, no? From where? I can look at this. IE equal to IC plus IB. So what is IC? IC should be less than IE. So what is the current gain of common base amplifier? Will be less than 1. This alpha will be, it will vary from 0.99 to 0.9. Like this, I'll adjust it. Just I think like they've common base amplifier not there, but in JEE Main they've asked it. What is the current gain for common base amplifier? It will, the value will range from 0.99 to 0.9. Just information. Later on C amplifier, when I go